Okay, so I have meters, 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 and meters. So that is dimensionally correct. What about the next one? Is it dimensionally correct? No. And you can see here I have meters per second right here. I have meters per second squared here. And then I have 1 over t, which is 1 over seconds. So this is my acceleration right here. And this is that 1 over t, 1 over seconds. So this becomes meters per second cubed. So I already know that it's not okay, but I can go further and say, well, the half drops out, x is in meters, t is in seconds. So there's really nothing about this that's dimensionally correct. That's useful. One, it just sort of builds your algebra skills, which you'll need for this class. But two, also, if you come upon an equation or expression, you can look at the units and get some idea about what that's trying to tell you. So for example, if you come up with an expression and it has basic units of distance or meters, then you know that it's telling you something about how far something has traveled or some position of something. It's a very common skill that scientists use, where not really worried about all the details of the equation, but we just look at the units and see what the units tell us about an equation. And you'll have specific questions where I just give you an equation or multiple equations and ask you which ones are dimensionally correct or not. There's several examples in the old test, but let's do an example right now. It's a quick test. Here we have this equation. It was kind of complicated. But I want you to tell me, is this equation dimensionally correct? That is, do the units on this side, x, a, m over t, equal to the units on this side, 1/2 mv squared a over b? Are those units all the same? And then I give you the units over here for each of those variables. Is it dimensionally correct or not? There's a hard way and an easy way to work this. If it looks difficult to you, think about it just a little bit, and you might find the easy way to work this. Feel free to ask your neighbor. Try to wrap it up soon. Okay, about 15 more seconds. Stopping at 2:30. 2:30. I know a lot of you haven't answered, but just guess if you don't know. I'll go to 2:35. Guess if you don't know. Yeah, your iClick. Yeah. So either A, yes, B, no. I'll go to 2:45. Just get it next time. It's okay. Listen, guys, if something happens to your clicker in class, your batteries run out or whatever, don't sweat it. Just sort of say it's going to be okay. I have it sort of built in, so if you miss a few days here and there, or if you miss a few days, that's not a big deal as far as your class participation. Just come to class and try to get as many questions right as you can. Because when you get them right, they count what? Double, right? They count double credit. In the end, like all my regular attenders, which will be most of you, will get that full 50 points. And then, some of you, unfortunately, will sort of stop coming here or there, and you won't get the full 50 points. All right, let's see what we got. Okay, A is right. I said there's a hard way and there's an easy way. The easy way is to do this. I can cancel my A here. I can cancel my M here and here. I can cancel a V here with one of those, right? Because it's V squared over V, V times V over V. And I'm just left with, gosh, what am I left as? X over T on this side equals V. We've already seen that, meters per second, meters per second. So A is the right answer. If you come across one of these and it looks really complicated, try to look for things that will simplify it in that way, similarly to that. Because I don't intend for you to spend 5, 6, 7 minutes on a single problem. On the test, you have to spend, a couple of minutes max on a problem. Some of the problems you'll know within a few seconds. But some of them you'll have to spend 2 to 3 minutes on, but you need to be pretty quick. And the questions that we do in class are meant to help you do that. It's a nice place where you can get things wrong. You can ask your friend what they put and not sweat it if you get it wrong. Okay, just briefly on uncertainty. We did this in lab. We talked about systematic and random uncertainty. Some of you are doing lab today, I know. And what do you call your instructor in lab? Dr. I don't. It's okay. We figure it out. And I'll just say, hey, you. I think she's okay with it. I mean, she's kind of mean, but you'll see what I mean when you meet her. She's not really mean. Don't tell her I said that. Okay. The uncertainty of a measured value depends on your method of measurement. So some methods are just more accurate than others, right? Like we saw in lab yesterday, it's more accurate to use a micrometer than to use a vernier caliper, and you'll see that in lab as well. Now the uncertainty tells you how well you know a value. So take, for example, I have this measurement for X, which is a position, and I measure it to be 4.5. But by my method of measurement, I have a certain amount of uncertainty, 0.2. That means that X potentially has a value anywhere between 4.3, that's 4.5 minus 0.2, to which value? 4.7. And we'll assume that it's equal probability between those values. That's not really true. There's actually more probable for it to be at 4.5, and then it sort of falls off as a Gaussian. But if you go on to grad school, you might take classes of error analysis where you get all into that. All right? What's that? Sure. That's all there is about uncertainty. You may or may not see that on the test. Sometimes it is, sometimes it's not. I don't consider it terribly important for this class. But it'll just be something along these lines. Which of these, like I'll give you a number with this uncertainty and ask you, what is a possible value for this measurement? Okay? May I go down now? Yeah? Okay, sig figs, significant figure, is a reliably known digit. Significant figures or significant digits. The cool people in class call it a what? Sig dig. Yeah. Now I know who's cool and who's not cool. Okay, I think y'all know the rules intuitively. I have a little video and then we'll do some examples. Okay, let's just try these. 0.1. How many sig figs does that number have? 1. It has 1 sig fig. Only this digit is significant. This 0 is a placeholder. And that's really the tricky part with sig figs, is knowing what the zeros do. How about this next one, 0.0054? It has 2, the 5 and the 4. The zeros are all placeholders. How about 102? 3. What? What about the 0? It's what? is between two non-zero values. It's not a placeholder. It has 3. And 100.1, it has 4, and 100.007, it has 6, right. So the easy way actually to tell which digits are significant is to write it out and sign. Oh, let's do this one too. I'm sorry. 0.00540.
Agree.
Oh, good. It has 3. The 5 and the 4. This 0 is not a placeholder. It's actually a reliably known digit. So this has 3 significant figures. When you write numbers in scientific notation, all of the digits are significant. So let's do this for each of these. This would be 5.40 times 10 to the minus 3, right? I have my decimal point here. I move it 3 spots over to the left. Here it would be 1.00007 times 10 to the what? 2, right? And then this would be 1.001 times 10 to the 2. Y'all should know scientific notation, but if you don't, that's not a crime, but come see me and we'll take care of it. This is 1.02 times 10 to the 2. Notice 3 sig figs here. And then this would be 5.4 times 10 to the minus 3. 2 sig figs. And then this would be, was this 0.1? Yeah. So it's 1 times 10 to the minus 1. So that's the easy way, is write it in scientific notation. Listen, it's not really such a big deal after this test, but on this test you'll have a couple questions that are dealing specifically with significant figures, and I'll show you what I mean by that. Primarily you're going to have mathematical operations. I'm going to have to make sure that you carry the proper number of significant figures, and we have 2 rules. The first rule is that when you're multiplying or dividing, use the lowest number of sig figs. So for example, here this would be, if I put it in my calculator, it would be 410.2. But that's not the correct answer. What would be the correct answer in this case? Keeping the lowest number of sig figs between this number and this number. Think about it for just a second. And now say the answer. 400, right, because this has 4 sig figs, this has 1 sig fig, so the answer would be just 1 significant figure. So the answer would not be 410.2, but 400. Because while I might know this number really well, I don't know this number really well, and that has to be related to the answer. This next one is 42.075. Think for just a second. What should it really be? 42. Because I have 3 sig figs here, 2 sig figs there. I just keep 2. All right? And go down. The next rule is for adding or subtracting numbers. Use the smallest number of decimal places. So for example, if I have this, it would be 132.7. But here I have no decimal places, and here I have 1 decimal place. So really, I would give the answer as 130 what? 3. I drop the 7 and round up to 2 because this 7 is bigger than 5. And by the way, rounding, I know some faculty use funky things for rounding. We just do it normal. If it's a 5, you round up. If it's below a 5, you round down. So an 89.5 is a 90. Actually, the correct way to write that would be a 90 with a decimal point, because it has 2 sig figs. This, by the way, that would be an A. And this would be an 89. And this, by the way, that would be a B. I know some of you are sad with these, and some of you are happy with these, but an 89.4. Okay? Okay, so on the test, what you'll see is something more like this, where you have combined operations. So when you do these, different people sort of have different philosophies, but I say you just follow the order of operations and you keep sig figs as you go through the order of operations. So you just keep the proper number of sig figs for each step. So the steps that I would do first here would be these two steps. I do this, keep the proper number of sig figs, which would be how many, by the way? It would be 1. Do this, keep the proper number of sig figs, which would be 1 digit, and then add those two numbers, keeping the lowest number of decimal places. So 3 over 4.2, that is 0.714. And 2 times 6.75, that's what, 13.5. So I'll rewrite this as 0.7 plus what? 10, right, just keep one significant figure. And then that would be 10.7, but I would rewrite that as not 10, but 11 because it has a 7 on it. William, you raise your hand. Why 10? This was 13.5, but this has one significant figure, and this has 3. So my result will only have one significant figure. I know, like, I want to put 13 too. Is that what you wanted to put? Yeah, that's what I want to do too, but that's not correct because I don't know this digit well enough in order to say that I know this digit that well. I only know it to the first place, to the one significant figure. Thank you for asking. I know, I felt the same way. It's like, I feel like I'm getting gypped or something, right? Like, I know this better than 10. Or 13, or 14, or whatever. Okay. You go down, y'all? Any other clicker question next? Yes. Let's try this. Try doing it without your calculator. You may use your calculator, of course, but try doing it without your calculator. I'm going to scroll it up so people in the back can see. I just want to know, what is the proper answer of this? If you put it in your calculator, you get 0.002941. Okay? But what number of significant figures should I keep for this? Feel free to ask your neighbor what they put, okay? All right, I'm going to stop at 115. 115. Don't think you're going to get a joke with this one. That's okay. It's still a good effort. It is A is the right answer. Notice, look, I have 2 sig figs here. And how many sig figs with 0.01? 1. So that's my limiting factor. I'm going to have, it's going to be 0.01 divided by 3.4. I have 1 sig fig in the numerator, 2 in the denominator, so the final answer will be A. All right, I don't know it as well as these answers lead you on to believe. The right answer is A. Let's try another one. How many significant figures should this final answer have? So don't worry about the answer, what the answer is, that doesn't really matter. Just how many sig figs should it have? How long do you have? I don't know, another 10 or 15 seconds or so. I'll give you a warning. Most of you have it wrong. Just want to give you a warning. I'm going to stop in at 105. 105. No, most of you think it's B. And the reason you think it's B, 2, is what? Which number makes you think it's B? 4.1. Ah, but look, you're adding here. You're not multiplying. So when I add 4.1 to 0.920, oh wait, no, 2. Let me think. No, you're right. I'm sorry. Oh, I'm sorry. Did y'all change your answer? I'm so sorry. Look, I'll give you a freebie, okay? So the answer is B. You can put in a B if you want. But do it quickly, okay? I'm going to stop at 10. I'll go over the answer in just a second. I'm sorry. I'll stop at 15. The answer is B. B. Yeah. Okay. This thing I'm going to show you here. All right. Should you get a joke? All right. I think I misled you there. Y'all change your answer when I misled you? I'm so sorry. You can forgive me. Hopefully this is a good joke. What did the fish say when he ran into the concrete wall? No, listen. See, when I tell a joke, proper joke etiquette says, or it says that you do not try to figure out what the punchline is, or say the punchline if you know it. You just say what? You say, or I don't know, right? What's your name? Damn, that's what it says. All right. Yeah, so let's see. So when I add these two, I keep the lowest number of decimal places, so that would be 5.0, and then that would be squared, divided by 2.54, and then when I do this up here, I keep the lowest number of sig figs, which is 2, 5.0 times 5.0, so 25 divided by 2.54, and then I have 2 sig figs here, 3 here, so the final answer, which you know is like 10-ish, 10 point, I guess, would be 2 sig figs. Okay, let's see what we got next. All right. It's not going to happen every day, but I'm going to let you out early today. Okay? 30 seconds.